Society Science Chat.
Now,
Here you go. Welcome to the John Chappell Natural Philosophy Society Science Chat for September 15th, uh, 2018. The uh, we want on the screen you'll see the information on things you can do, participate more fully in the organization, and on both and even on Facebook and on Wiki and Uh, and if you are, want to be a member or already are a member, please renew your membership once a year so that we can keep the organization functioning and don't go bankrupt. By the way, I had a call yesterday from the one of the person who is still in charge of the Natural Philosophy um, Alliance (NPA), from which the Chappell Natural Philosophy Society came from, and they are not functioning, and we're trying to figure out what to do next. And so uh, we need to keep ourselves moving and functioning so we can accomplish something in the scientific area. Okay, we were talking before we started recording on the fact that the scientific method, uh, starting about 1850 or 60, was changed to the existential scientific method. And that change had to do with the removal of the role of logic, part of the role of logic in falsifying theories. That the existential philosophy of science says that assumptions were a theory to be able to derive the formulas, like there are assumptions for special and general relativity that allow you to derive uh, certain laws, and those assumptions are uh, known to be false. So by having an existential philosophy of science, no theory is falsified anymore by using false assumptions. And the but then we ran into trouble. Certain theories, again, like relativity theory, general relativity theory, could not predict the forces measured by Pioneer 10 and 11 in our solar system. They could not predict the forces in the outer arms of spiral galaxies. So even though the existential philosophy of science allows the falsification of special and general relativity because they can't predict the observed data, they decided not to do that. What they did is they invented dark matter and dark energy to take up the slack that what general relativity theory cannot predict. And and so they have now removed all of the methods for falsifying the theory. And so we have a regression of modern science. And it got even worse in the 1960s when the existential philosophy of science was changed again to be what we call the postmodern philosophy of science. And in the postmodern philosophy of science, each field of science became a separate silo. Silo means they're independent of one another. And what are those silos? Well, physics, chemistry, biology, astronomy, geology, etc. And so the university is no longer a university, it is a multiversity because each of these fields are considered independent of one another. And so in our universities, what do you have? You have a physics department, an astronomy department, a chemistry department, a biology department, a geology department. So you have all of them separated, and they have their own sets of journals and their own set of referees that determine what will be allowed in their silo. So, for instance, one of the things that interested me was that the chemists discovered that the force of gravity in chemical laboratories is electromagnetic in nature and is related to the force between vibrating electric multipoles in chemical processes. And they were able to see that, and they were able to derive the force of gravity from just working with multipoles, so dipoles, quadrupoles, octopoles, etc. But that information was not allowed in the physics side. So, do physicists recognize that gravity is electromagnetic in nature? No, 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 no. Do chemists? Well, yes and no. Yes, they know about it. They publish it in their journals, but they're not responsible for the theory of gravity, so they don't make an effort to tell physicists, hey, look, we found that the gravity is electromagnetic in nature and origin. They don't do that. So now we have all these silos, and this makes it easier to maintain the politically correct theories that some people want. And so then the question is, why do they do that? We didn't do that in the past. Why are we doing it now? And I'm writing a series of papers for Common Sense Science newsletter and their journal called Foundations of Science, in which I've documented the regression of modern science. And so far we've published five papers on that sequence. And I'm trying to use circumstantial evidence to identify the origin of the reason why this occurred in the scientific community. And it's a very interesting reason, and it's interesting that Einstein knew about it. But he never told us, other than a note that he had written to himself in a kind of like a memorandum that was found after he died. And it's in a book I have, which is quotations of famous people in the history of the world. So people realize it was a famous quotation, but what he said is, we keep these a secret, the reasons why we do these things. And so I'm trying to use circumstantial evidence to uncover the reason why we adopted the existential scientific method and the postmodern scientific method. And when I went to school, I went through a major in physics and got a master's degree and a PhD, and I did postdoctoral work. Nowhere in all of that did anyone ever say anything about it. They didn't even emphasize the name of the philosophy.
They didn't say anything about what, Bill? They didn't say anything about what?
About why the existential philosophy of science was adopted. Why?
They don't even know that such a thing exists.
That's right. I didn't know such a thing existed either. Now I know.
Well, the basic bottom line is that I don't think there is a scientific method. I think that scientific method is just something that they put in the first part of these books. And, and they say scientific method in the introductory chapter, and they give you the standard scientific method. And then, and then they proceed to go into the book, and you never hear about it again. And so, it's just, PR, basically, as far as I'm concerned. Scientific method is nothing but PR. It's their excuse for saying that what they do is right. And if you challenge it, they, of course, can't allow you to challenge it because they're right because they say so. So they have a lot invested in appearing to be right. Notice I said appearing to be right. So it's not really about being right. It's only about appearing to be right. And that's really what the problem is.
Yeah, and so um, for instance, before we got to these philosophies of science, like in the days of Isaac
There
Newton.
really isn't a philosophy of science. If you read the philosophy of science books, they'll tell you there is no philosophy of science. There really is no scientific method because they can't agree. None of the experts who study the philosophy of science or the scientific method can agree that there really is such a thing.
Um, well, I have been doing a lot of reading on the internet and some books on the philosophy of science, and they do identify the philosophy by name, but they don't say precisely why. Um, Part of it is like uh, in the development of quantum mechanics. Quantum mechanics was losing touch with the law of cause and effect and starting out in a new direction. And that certainly needed a change in the philosophy of science in order to let such an approach be. Uh, uh,
Well, yeah, they had to change the method and the philosophy behind it and the assumptions to justify that the new belief system was correct. So what they do is they just establish the scientific method that justifies the belief system that they're currently using. That's all they're doing, really.
yeah, and but they try to make it like we're improving science over time. I mean,
Well, the other thing they do is they basically confuse you with the BS and all of the, they bury you in nonsensical, methodological, nonsensical, so you get trapped in, if you try to challenge it, you get trapped in all these extraneous red herrings that they put out there that are really basically designed to make it look like they know what they're talking about and you don't. And so you're kind of in trouble if you try to challenge their methodology and what it is they're doing.
yeah, yeah, and so anyway, uh, I've mentioned before that in my scientific career, um, I was only vaguely aware of some of these things, and uh, I didn't realize how important it was to the scientific community to maintain this political correctness. And so when I gave a talk once before the American Physical Society, and I showed that there were a number of assumptions of special relativity that are known to be false, and I gave what they were and what the data was that falsified them in a presentation before the American Physical Society. They had me fired in 24 hours from Catholic University, where I had a position, for saying that, because that was not allowed. And and so I was saying that on the basis of logic, if the assumptions are false, then the theory cannot be claimed to be true. It may effectively explain a lot of data, but it doesn't necessarily mean it's true. And so that was the end of my academic career, because once you are blackballed for doing something like that, that's the end of your academic career. And it happens to many people who discover, as I did, uh, something, and then they think this will help us improve science, and when they express it somewhere officially, that's the end of their career. And I've had my colleagues and friends at University of Virginia, University of Louisiana, and places like that lose their jobs and have to do something else for a living as a result of publishing a paper. related to these type of things.
Well, there's no question that universities are political organizations. I think that anybody who doesn't really understand that, most people I don't think understand that, but universities are primarily political organizations, meaning that they have to adhere to the political winds or whoever's in charge because they get all their money from the government. Okay, they get their money from the government.
Except
Only universities that don't get their money or their majority of their money from the government can really basically be independent, okay, of the political system.
yeah.
So they have to adhere to the political system because that's where they get their money.
Yeah.
Now, unfortunately, we've been told that the university systems have things like academic freedom and all of these, quote, safeguards that are supposed to protect us from the universities becoming tools of the political system, but that's not the case at all.
Yeah, well, one of my sons went to Harvard, and Harvard has a endowment, and the endowment is larger than the gross national product of all but 5 nations on earth. So it's
somebody is running that endowment.
Is that pardon?
Somebody is running that endowment.
Oh yeah, they have people that work in the area of finance at Harvard, and so they are investing in things like the stock market, and they're.
Yeah, I realize that, but you have people who are being being told by the president of Harvard, to adhere to the politically correct viewpoint.
Right. Even though they don't need the money, they get some from that.
Well, there's a lot of external pressure. I mean, the president of a university doesn't want to be criticized by CBS or ABC or NBC or anybody in the journalism industry. So, obviously they're going to produce journalists out of Harvard who are going to adhere to whatever the journalist ethic is or the philosophy of journalism, and they have their own rigid rules about whether or not you can be allowed to express an opinion. And if you express an opinion in journalism that doesn't conform to the opinion they want, they fire you.
Uh-huh.
So, the system basically, is political, and that's how it works. So there's no reason that science would be different from that.
Is there a quick break in? Does anybody have a solution of how any suspect or anything of how you can break into this? Because it seems to me like, this natural philosophy organization we have has great people and great ideals, but they never get out into the mainstream. Does anybody have any ideas how to break this?
Well, David DeHilster has been working on this. They're pretty rigid, and if you know the history of the NPA, you'll know that this woman wrote a book where she talked about the NPA in extremely negative terms. And I can't remember her name, Wilhelmina or something. Does anybody remember her name? Wertheim, wasn't that her name? And she pretty much described the NBA as kook science.
Was that Dr. Wilhelmina Koza Spencer?
I don't know who you're referring to.
No, not Spencer. She was at.
No, it was Wertheimer, I think.
Yeah.
You familiar with this episode, Jack? That actually led to the dissolution of the NPA.
That negative book.
Well, she used the word fringe science. I guess I was a little incorrect there in my terminology. She used the word fringe science, as I recall. That was basically the start of the dissolution of the NPA, because a lot of the people who were in the NPA said, "Oh, we've been marginalized by this book. And so obviously we have to clean up our act and do something." And so what they did was they marginalized David DeHilster and a number of other people. And that led to the dissolution of the NPA. I think that's a pretty clear example of what happens.
I think there were some other factors too that were involved, but yeah, these are all factors. And
Does that help you any, Jack, to understand the politics of the situation?
Well, I guess I understand the politics of it because I've gotten many of the my belief systems at the current time came from a huge number of the writers on the NPA, and I don't see any way to ever get it published. I'm just publishing a few books on Kindle just to see if anything will happen from a few things like the fine structure constant. A model of the electron by Professor Karnarev in Russia explains the fine structure constant with one simple little formula, and it's really hard to argue with it. But I don't think it would ever take off in mainstream media because it's just not their philosophy. So the biggest thing I'm looking for is any way to break through this barrier that the universities have set up, that we're the experts and you will do what we say as experts.
Well, like I said, David DeHilster's been working on that issue for quite a few years.
Has anybody seen any, like Bill, your story to me is like incredible, that you're a PhD graduate, you disagree with them and they just kick you out. You have to find a different way to make a living. That's incredible.
He's not the only example.
Well, no, I think there were at one time as many as 500 people we knew of in the United States who had similar things, who had been in universities and had to leave and do something else for a living.
How can we beat them?
The idea is everybody has to say the same thing, and that's kind of interesting. There's no allowance for different voices because that confuses the public. The public is confused if they don't get a monolithic explanation of science. In other words, science has to always say the same thing. All the spokesmen have to say the same thing because they need the money and they don't want to create the impression that they may not know what they're talking about.
Okay. What I was going to say is I've been studying the history of science for some time, and what a lot of people say is that it takes the passing of a generation before the new ideas can be accepted. And so, like you take people like Galileo and stuff like that, it wasn't until the next generation came along that their work was properly recognized. And but they were fighting against a number of different parties in the university and even in the church at that time when they had the theory of gravity and the Earth is going around the sun, it's not the center of the universe, and all that kind of stuff. And but after a generation died out that was enforcing that, the next generation thought it was pretty good. So what you need to do is get the word out, even though it's not acceptable, and hope that the next generation will pay attention to it and not pay attention to their peers or the people that their mentors who taught them, and they realized the mentors were not correct. And so it takes a real community of people supporting your work to eventually get it accepted. And
so, Bill, have you ever looked into the issue of the sound barrier? Are you familiar with the sound barrier?
You mean for sound, 700 and some miles per hour?
Well, yeah. My father worked for NACA back in the day. Okay, during World War II, yes. And in those days, it was believed that you couldn't go faster than the speed of sound. And of course, all the academics believed that. And So, you know, Bell had this plane, NASA was an NACA in those days. They had a plane called the Bell X-1, and they were going to try to fly faster than the speed of sound. You're familiar with this. There's, of course, Chuck Yeager was the pilot. Okay, now I've got this book by Chuck Yeager, his biography. Why do you suppose they selected Chuck Yeager to fly in this airplane? Well, I'll answer the question. He didn't have a college education and didn't know that the academics had proved that it was impossible to fly faster than the sound barrier. Any of these college-educated test pilots, they were scared to death because they believed that the academic idea that the sound barrier was impossible to break, and they didn't want to kill themselves.
Yeah.
So they got this guy, Chuck Yeager, who had only a high school education and an Air Force pilot, and put him in there, and he broke the sound barrier. Okay, so what was the reaction to this belief that there was a sound barrier that was impossible to go faster than? What happened to them?
Well, they eventually accepted it.
Well, he proved that it was wrong concept.
Oh, yeah, but we proved a lot of things like that in our work that we're doing in research, but it doesn't mean it's accepted right away. What they're saying is sometimes it takes a new generation to accept it, because the old.
Well, in this particular case, a false scientific belief went by the wayside by basically a pretty dramatic demonstration of a guy flying an airplane faster than the speed of sound, and all the academics who believed that that was impossible were proved wrong.
Yeah.
Right then and there. I mean, there was no doubt about it. I mean, they were just flat wrong.
Yeah.
Hey, a quick side note on Chuck Yeager in 1979. We were suiting up for a flight out at Air Force Site 5, and that conversation was raised about his original speed of sound, and he laughed about that they said it was impossible, and what he told them was that the bullet has already exceeded the speed of sound. This is just bigger, and he says in his minuscule understanding, he just pulled a classic example out of everyday life where they were dead wrong.
Right. But you don't hear anybody, you know, as an example of a scientific theory being exploded instantaneously. You don't really see that as an example in any of the philosophy of science books. I've never seen that addressed. And generally, they're relatively silent about this particularly embarrassing episode. And I think it's a pretty spectacularly embarrassing episode where all these experts, you know, essentially, if you read his book, you know, the implication is they thought he was an idiot for doing this. You know, all these college-educated test pilots, you know, they didn't really want to have anything to do with this because they thought anybody who tried it was going to die. Okay? So, but you don't, but the bottom line here is this was something that was fairly easy to disprove experimentally just by doing it. The difficulty is that modern science is in the situation where it's not really that easy to do simple demonstrations that disprove the theory. So the ability to disprove the theory is extremely difficult. And on the other side of the coin is there's really not a whole lot of people that want to fund efforts to disprove the theory because you have to have some kind of a motivation to disprove it. In the case of the sound barrier, there was a lot of motivation in terms of military advantage to disprove this thesis or theory. And so there was money, and the military was interested in disproving it very quickly because they saw a military advantage to be gained. But in disproving other scientific theories, what is the advantage to be gained?
You know, one of my sons did a science fair project on the using the toroidal ring model for the electron and in the atom, and he was able to predict twice as many spectral lines as the current theories of the atom, like the Bohr model, the Schrodinger model, and Dirac model of the atom. And then in his science fair project, we discovered that NASA had done an experiment where they put a rocket out on the dark side of the Earth, and they opened it up, and they looked toward the darkest part of the universe, and they had a grating there, and the radiation that came in from space with no glass window or anything came in, went across the grating, and then divided up into many spectral lines, hundreds of spectral lines. And so NASA looked at that and said, this should be spectral lines from hydrogen and helium atoms. But no theory is in the extreme ultraviolet that they were looking. No theory, no model of the atom predicted even one line in the extreme ultraviolet, much less hundreds. Then my son looked to see what the ring model would produce, and it predicted every single line that they measured for hydrogen and helium in the extreme ultraviolet. Every single line. He went to the International Science Fair, which happened to be in Hamilton, Ontario, Canada that year, and the Nobel Prize winners said, we refuse to judge this project because it is absolutely wrong. It's not the politically correct theories. But NASA was judging for the grand prize at the International Science Fair. And even though my son received 0 in the physics category, he did receive a grand prize because NASA said, we took the data, we know it's valid data, and this project has explained every single line we measured within our experimental resolution. And by the way, the experimental resolution in space is better than the experimental resolution on the Earth. And so it's the most accurate, the spectral lines have ever been measured. They measured 7 orders of each line. 7 orders. Now it's like you've probably seen the rainbow in space, and sometimes you'll see a second or maybe even a third order of the rainbow, but you don't get 7 orders. And the same thing is true in the laboratory. And so, but did the world accept it? No. However,
what would be the advantage of accepting this theory, Bill?
You would have a more correct theory of the atom.
But is anybody going to make any money? Is anybody going to be able to build a better weapon system? Is anybody going to be able to develop a company to create a lot of jobs? What would be what's the economic advantage, or whatever, what's to be gained?
Have you ever heard of the nanotech crystal that's going to replace the solar panels?
Well, but you're arguing, what I'm saying is that only when there's some kind of advantage to be gained that can be shown to people that, hey, this is going to give you some kind of a military or political or economic, you're going to get rich or something like that.
Yeah.
Is there going to be some kind of action? If there isn't, then I don't think you're going to get some kind of action. Another example in this would be Marconi's invention of radio. I can tell you for a fact that there's probably not any scientist that believed that Marconi could have invented wireless telegraphy. I don't think there were any scientists at the time that said that what he did was possible.
But eventually, later generations accepted it and used it.
No, it was accepted because Marconi made a bundle of money out of it.
Uh-huh.
And a lot of other people made a bundle of money out of it because it was a practical invention that worked, and they made tons of money.
Yeah.
Okay. He got investors who invested in it because they wanted to make money.
Right.
Okay.
Now, this nanotech crystal is the biggest technological change in 200 years. And let me describe what it's going to do. This crystal is able to receive the extreme ultraviolet radiation coming in from space, some from the sun, but mostly it's coming from the other stars, and convert it to electrical energy. Now, if I have a solar panel and I put it on my house, it usually requires 10 solar panels to power a house, and they're big. This nanotech crystal produces 100 times as much energy per square inch as a solar panel does. And it works 24 hours a day. It doesn't have to have the sun up to work. And so that means instead of having 10 solar panels, I can just put a very tiny panel up and get the same amount of energy. And in fact, we have discovered that you don't even have to put it on the roof of the house. You can put it inside your house. You can put it up as your window. You can do a lot of different things. You can power your car. And in helping to market this nanotech technology, Tesla took a car and made it that ran on this panel. This car has no batteries, no transmission, has a very tiny panel on the roof of the car, and they showed that they could go from 0 to 400 miles per hour faster than any car ever made in the past. And this company that's making it says, okay, any car manufacturing company that wants to use this in their car can, but you have to put up $1 billion to our company. Well, every major car manufacturer in the world has put up $1 billion. In fact,
Bill, what's the time frame for this technology coming out on the market?
well, in the European Union, they have passed a law that says after the year 2030, no more gasoline or fuel oil powered cars will be allowed to be sold in Europe, in the European Union. Great Britain,
They're in big
France,
trouble. They're in big trouble.
And they also said that after the year 2040, no longer will any type of fuel oil or gasoline be sold in the European Union.
Well, like I said, they're in big trouble.
Well, the panel seems to work. But what I'm saying is,
okay, let's just
now what produces?
Let's talk about something realistic here.
Okay, let me finish. What is it? It's the extreme ultraviolet energy coming in to these panels that produce all this power. You can't explain it with the current theory of the atom. Can't explain it at all.
Like I said, Bill, people aren't going to change because the government made a regulation that you can't sell cars after 2030.
But
there needs to be somebody who is got money or somebody in the government with influence who sees that there's a way for them to get a lot of money, to get rich, get famous, get political power or whatever by introducing some kind of scientific innovation.
Okay, now
outside of that, people will adhere to the current way of doing things.
Right.
So there has to be some kind of external entrepreneurial driving force that creates the change.
Okay, now this company has already received, this is a California company, they have already received $1,200 billion from third parties who want to use their crystal, which they've demonstrated for these companies. And that they've given a crystal to the company to investigate and experiment with and all that kind of stuff. So they know. They wouldn't
Bill, what's the name of the company?
If it didn't work.
Bill, what's the name of the company?
you have to pay. I get these stock market newsletters. You have to do a subscription to their journal to get the name.
Okay, you can't give it out. All right.
And anyway, they claim that they think that you invest in this company, like these 1,200 other companies have done, they think that your investment may yield between 10 and 100 times return in just a few years. Because this is what they're predicting. There will no longer be power plants in the world, like electrical power plants. There will no longer be electrical outlets in the house. Everything that you use in the house that requires electricity will have its own crystal and won't need any more. Your radio, your TV, your washer, your dryer, your dishwasher, your furnace, your air conditioning, all of those things will have their own crystal inside, and they don't require any external power. And so it'll be easier to make houses. It will be easier to make cars. The cost of a car to make with this crystal is less than half of the cost of currently making a gasoline or fuel oil powered car, because you just have simple electrical motors. You don't have any batteries. You don't have any transmission. The car is lighter. It goes much faster. Will last longer. All these things. So,
well, I'm looking
Bill,
forward
do you
to
have
it.
any information on the frequency of this UV they're using? The frequency of the UV that they're using?
It's the highest energy that we have ever observed associated with an atom. It's in the extreme ultraviolet.
That should work. Okay, that makes sense. Actually, Professor Kondarev's work actually verifies everything you're saying. So it should work.
Yeah. So anyway, my son did this science project, but it was rejected by the politically correct scientific community. They refused to even judge the project in physics, even though it was an international science fair. All the judges at the international science fair in the different fields were Nobel Prize winners, not just normal people who were really aware of what's going on in the scientific community. And yet NASA overruled all of them and said, look, this works. We know. We've done the experiment. No one else can explain these experimental results except this science fair project. But as a result of that science fair project, my son had graduated first in his class from a science and tech high school. He applied to California Institute of Technology, Caltech, and they said, we've never had anyone from your high school come to our school. We don't think it's very good. We reject your application. He called them back and said, I just won the grand prize of the International Science Fair. And they said, oh, you did? Oh, we'll give you a full scholarship. And, he went there. But then he realized, boy, this is a tough road to hoe, being politically against all of the different parties, that are in the scientific community. And so he left Caltech and went to Harvard, but he discovered the same thing there. And he decided to change to another field. They went into law. And but that's the kind of thing that's going on in our societies. And
what was the name of that company in California with the crystal again?
I don't have that. It's I'd like to say I'm the newsletters give you the name in terms of the stock market acronym, that you use to buy and sell stock. But in order to get
symbol.
in order to get that, you have to subscribe to the newsletter, which usually is about $600 or $700 for the year. And I haven't paid that money out because I'm not currently doing that type of investment. But they claim it is one of the best investments that you will ever experience because of the potential of what it can do to America.
I just Googled nanotechnology crystal electricity and have 50 things popped up immediately explaining the whole thing.
Uh-huh. Well, if you could find the name of the company, that'd be good. But see, all these companies that are put up the $1 billion, they're going to be putting these crystals in their product. And like, for instance, Apple put up $1 billion. Why did they do that? They want their cell phone to never use batteries and to work all the time. So they put up $1 billion for it. And Amazon.com put up $1 billion for it, for the different businesses that they run. And
Yeah, Bezos pocket change.
for them, yeah. But a lot of companies have had to borrow that money because they didn't have that much. But they realized, I will be out of business if I don't have this technology in it when it comes out. And after a while, it would be too late to get in. And so that's what's going on. So anyway, there's something coming, and it may have the effect that we would like, unless somehow the politically correct scientific community comes up with an alternative explanation of how these crystals work, not based on the current theories of the atom, but something else. And so we'll see. They may come up with a new type of radiation that we never, not black body radiation or black hole radiation, but some other kind of radiation, that we can now capture. But
hey, Bill.
Yeah.
Yeah, I'm wondering how anyone would make any money off of this. So I go and buy their crystal, and I'm set for life. There's no continual revenue stream. I don't see a business model for that. So, I'm kind of, well, it might be great technology, but would they really let that out? I mean, would they put it in a product? You have one thing, and it will run my house, it will run my car, or I make one payment.
Did you realize if you just bought a car with it, you could run your house with the
exactly
off the car? And so, but on the other hand, how many people in the world would buy one if they didn't have to buy any more energy source for the rest of their life?
If you go to the archives for the Extraordinary Technology Conference at 06, there was a speaker there that gave a full definition on the crystal, just the 2006 conference.
Uh-huh.
Even does drawings on the board and everything, explained exactly how it worked.
Oh, great. So
what's that reference?
That's the Extraordinary Technology Conference 2006.
So we just Google Extraordinary Technology Conference 2006.
Yeah. You can order the DVD or get a Vimeo online. They've
Do they
got
have
the DVD
any
there.
demonstrations that this works?
Yeah. There was it wasn't on the DVD, but it was done quietly at a restaurant that evening at the conference and at the hotel.
Well, as I was discussing before, one of the things that Marconi did was he had a massive PR campaign because it was pretty obvious that he was facing a lot of opposition from the establishment science community. And he got the press and the journalist community, everything that he did, he invited them in and showed them that it was working and got them to give him a lot of PR. And that doesn't seem to be the case in this particular example.
Well, the folks involved with it were still hoping to, as you carefully pointed out a little bit ago, capitalize and basically get themselves to the point where they could sustain a living working on the technology.
Well, the PR would be an advantage, wouldn't you think?
To some degree, that's correct. The difficulty is that the patent office was never made to protect technology. It was originally set up by the aristocracy in Europe to farm energy or farm ideas and technology off of individuals that couldn't afford to hang on to it, and with the supposition that or the perception that it was some level of protection, and hence the reason why they only went a few years, 7 years, et cetera, et cetera. And the individuals were concerned about that taking place, and it's still taking place, and the ones that originated the technology still have never.
Here again, one can point to Marconi as an example of difficulties involving patents. If you want to take a look at that, that's another example of the technology involved lots of patent disputes, and people basically resented his patents.
Yes. Yeah, one of the proprietors of that technology, the crystal technology, has now since passed away, a pauper.
That probably could be a problem.
Yeah.
Well, the company owns 250 patents with 200 more pending. So they're trying to.
Yeah, unfortunately, as Marconi found, controlling the patents doesn't necessarily prevent competition.
Oh yeah.
I
had those too.
For those of you who have patents that have been challenged, you already know this, but for the rest of you, your capacity to defend a patent is exclusively based on and directly coefficient to how many zeros you have between decimal place and some significant figure to the left of the decimal place.
Well, that's correct.
Yeah, my father was a patent attorney, and he helped people pay patents from occasionally, and you'd be surprised what goes on there.
Well, if you're very successful, like in the case of Marconi, who was very successful, people then attack you as being a monopoly, and then you get the government, trying to break your monopoly. In the case of the U.S. government, the military was very much opposed to adopting the Marconi system because of the monopoly aspects of it. And so the Navy was very, they didn't want to buy the Marconi system, which, you could sort of think of as being a kind of a mistake in a way. The U.S. Navy refused to buy it, and they tried to contract with a lot of other companies. But, then you get to the issue of, can you patent the concept of electromagnetic wireless telegraphy, since it's a natural phenomenon. But, the real point is that, once the idea had been demonstrated as being a practical concept, then it kind of became clearly part of established science. Now, one of the things to note about Marconi was that although Maxwell had predicted electromagnetic waves, the people in the telegraph industry didn't really think that it could be made into a practical system.
Well, if you just look at the cell phone, the first units that were demonstrated in things like Star Trek and Star Wars, they were big and awkward to carry around. But a lot of people thought, well, that's just dreaming, But then we now have very tiny cell phones, so the technology came eventually.
Yeah, don't forget Dick Tracy.
Well, my point that I'm making is that scientific change, to a large extent, occurs when somebody does a demonstration experiment. Okay, another example I'll give is Volta's experiment. There was an argument about the nature of electricity, and Volta did the did a number of experiments, and people couldn't argue with his experiments. Okay. So that was the way people did things to change science up until about the start of the 20th century. And I think that's what Bill is kind of getting at to a certain extent. And that is that, you know, if you wanted to advance your scientific theory, okay, you basically figured out a way to do an experiment or develop a technology using your theory, and then it became kind of an irrefutable fact. I mean, you had shown it to them that this was your theory and it worked, and you had a machine or something that used that principle and it worked, and there was no way they could, you know, refuse to accept it.
Well, I think if Apple puts out this nanotech technology in their cell phone, and there's a new generation of cell phones coming out. It's we have the 4G now, and the next one's 5G, and it's 100 times faster. You can download a movie in 10 seconds. And if people get that, and they get this nanotech technology crystal in their cell phone, they're going to believe it. They're going to say,
Yes, that's true, Bill. But the problem I have is, they're, you know, can they find a way to sort of explain it away, and you know, so that it's non-threatening to any of the core beliefs? Okay, that's really the issue. How does this disprove any of the core scientific beliefs that they adhere to?
Well, I don't think they're emphasizing that. The people that are marketing it,
Well, I certainly wouldn't if I was marketing it.
they're saying, look, we can make this crystal. And by the way, Saudi Arabia, who does a lot of selling of oil and stuff, has discovered that they need a lot of sand with silicon. The silicon is the basis of this crystal. And they have negotiated with this company to sell the sand of their deserts back to the company. And so instead of making their money on oil, they will start making it on sand.
Well, that seems like a logical thing to do.
Yeah, so they don't necessarily oppose it.
So still here the issue is, in the realm of modern science, and to go back to the Marconi example, if you try to read textbooks and books on electromagnetic theory, while we know that radio works and that it exists and it's, you know, an obvious everyday phenomenon, they still don't know what a radio wave is. They still don't understand EM radiation. So despite the fact that Marconi, and we've used this phenomenon every day, it still is something that's not at all understood scientifically.
Yeah, in the silos we consider electrical engineering a separate silo from physics. And so they can explain how the radio works, but they don't. The physics department doesn't do it quite the same way.
Which brings to the surface a plain concept that some things will never be fully understood, and which means that an inventor, scientist, or physicist will never, ever be able to satisfy the scientific community or just the shade tree onlooker in any way, shape, or form on understanding of the technology. But if they have a practical demonstration that it works, regardless of whether they know how it works or doesn't work, that sets aside the requirement to fully explain and define it, which is what most scientists and physicists spend their life doing, and those that are short on math skills have clear problems with that. In Einstein's case, he was so short on math skills, he had to have Mileva do all the math work.
If you look at the experiments that Tesla did, he did a public experiment in Colorado Springs where he transmitted power through the atmosphere to Denver, which was, well, I don't know, 60 miles away or something like that. And he ran a huge motor in Denver from the power transmitted through an antenna in Colorado Springs. But if you say, oh, well, that's not possible because the energy that he put out through the antenna goes out in all directions, and it goes down as 1 over r squared in terms of the intensity. By the time you get to Denver, you're not going to have much power. So the media was there. They saw it worked, but we don't have it as a technology today. And so Tesla was, and Tesla tried to patent it and everything. And so some things that we do is in terms of demonstrations get ignored. And it was when Tesla tried to build the big tower and to give the world free energy that his supporter, forget his name, a very wealthy man, just withdrew all support.
I think this is an example of conducted electricity is more efficient than radiated electricity.
Well, but see, what Tesla showed is he was able to transmit just enough power out of his transmitter to run this device in Denver, which required hundreds of amps of power to run this huge motor, and in Denver, and we don't know how he did it, because even if we put wires up there, we would lose a certain amount of power just going between the 60 miles, and that was quite unusual. And of course, in his day, it was mainly DC power that Edison was producing, not AC power that he was doing. And yeah, there's a lot of things, but there's an example where something was ignored, and we wonder how Tesla did all this, because he seemed to have some innate premonitions on how to design things, and unlike Edison, who would make something 1,000 times before he found a good combination that worked, Tesla seemed to be able to do it the first time. And we don't know exactly how he was so successful. He seemed to have, as I say, some kind of intuition that most people don't have. But
how many of you are familiar with the tungsten event? Paraphrase the Great Siberian Explosion of 1908.
Heard of it.
You can do a web search on it, but isn't it interesting that Tesla was experimenting with aiming or directing the energy and trying to figure out how to get it to a specific place on the globe, and that at the exact same time that explosion occurred, that he was in the middle of transmitting and hadn't yet perfected that technology. Isn't that interesting? That's just a thought-provoking moment for you.
Yeah. Well, my son was in the Air Force. He's retired now. And in Fairbanks, Alaska, we have what looks like 1,000 radio antennas, and they're putting up energy into the ionosphere. And then when the energy gets up there, they're able to shift the, what do you call that, big current of air, the jet stream. He was able to shift the jet stream around. And so they were experimenting to see what they could do with that, and they caused the Hurricane Katrina. But even while Katrina was going on, they didn't realize they had done it. And they were still doing things. And the Weather Service, where I was working at the time, they were saying, that we have all of our models fail. What is happening here? It doesn't do what it's supposed to do. And so that was because someone was interfering with it. Now we use that technology for military purposes and other things around the world, and so does Great Britain and Russia. And so we're experimenting still of how to change the weather and electrically. And so those are not, the government doesn't want to announce that they were responsible for the hurricane because they didn't want to pay for all the damage they did. And by the way, Great Britain destroyed one city, their cities, they basically washed it out to sea with a huge storm that they created when they were using these antennas for their purpose. And there are 5 places in the world where these antennas are used.
Okay, Bill, I'd like to change the subject to last Sunday, we have an article here in the local newspaper, Studying Subatomic Superglue. Jefferson Lab, as you're know, we have the Jefferson Laboratory sponsored by the Department of Energy here in Newport News. Jefferson Lab's massive GlueX experiment takes up search for an elusive particle. And as I understand it, you say there's no such thing.
Well, what I have done, I by the way, that laboratory used to be a part of William and Mary.
Correct.
And it was called the Space Radiation Effects Laboratory when I was in graduate school there. And so I have a certain amount of experience working with that. But one of the things that I learned in working with that is, as experimentalists, not theoreticians, but as experimentalists, we had our own idea as to when you identified an elementary particle. And our idea was, if you make an elementary particle, like we would take hydrogen gas and clear the electrons off and end up with protons, and then we accelerate the protons and bang them into a block of something like carbon or whatever, and make all kinds of elementary particles. And then we use filters and magnets and electric fields to try and separate them into different elementary particles, and we can make a beam of the different elementary particle. And I was working with beams of negative pions, negative kaons, and negative muons. And we made atoms out of it, and that was my thesis, was ionic, kaonic, muonic atoms, and what you could learn from those atoms about the atom. And since the pion, negative pion, was much closer to the nucleus, it actually went inside the outer part of the nucleus, and so you could use it as a probe of what's going on in the nucleus and that kind of thing. So we did all kinds of experiments of that sort. And but anyway, our criteria for what is, if you have an elementary particle, what is it? Well, you have to be able to create it. You have to be able to make a beam of it and perform experiments with it. If you can't do that, your theory says there's something, but the experimentalists can't see it, and they don't believe in it. And so that's how that works. So I was very skeptical, like on the Higgs boson. If you look at all of the experiments that they did, that they can't form a beam of them. They can't do experiments with them. All they can do is use theories to analyze what they're seeing when a certain thing happens. And they say, oh, well, that means there must have been another elementary particle called the Higgs boson with these characteristics. But that doesn't...
The bottom line is that in these modern scientific experiments, it's not something like Marconi invites a couple of newspaper guys and some people from the post office and some people from the Army and Navy, and invites them over, and he does this experiment where he transmits a message from a station at one point to a station at another point that's 15, 20 miles away, and they receive the message that he transmitted, and everybody can see it, and it's kind of obvious that what he did worked. Quite a bit of a different concept than what they're working with now.
Yeah. And but you know, when you look at the Tesla experiment in Colorado Springs to Denver, he was transmitting and receiving about a megawatt of power with just using the antenna. And you wonder, how could he do that so efficiently? Uh, and so, so anyway, and he had the media there. They were in both Denver and in Colorado Springs, and they were talking to one another, you know, on the phone and stuff like that. And so they had a lot of communication going on, and nobody understood how that energy was transmitted so efficiently. And we still don't know how he did that. And so his idea was, I can transmit very efficiently around the world, and everyone who has the right kind of receiver can get it. And so they would get free power, no meters, no wires, etc. And
Well, I doubt that it would be free, but
no, but that's what his sponsor.
well, there's no. I mean, you know, they'd be broke in no time flat.
Well, but they see he wasn't using any fuel to produce the power. So
A witness from the Colorado Springs event wrote down that a comment that he observed birds flying in the area around the antennas, and they were not killed, and actually they landed on the antenna, and some of them were flying directly in the path of what would be considered the transmission path, and with no ill effects, which raises some interesting questions.
oh yeah, some people thought the power actually went through the surface of the earth somehow, and they managed to pull it up in. But
Actually, it does. Actually, if you look at the everything he wrote on it in the patents, he makes it very, very clear. And if you look at every current, whether it's AC or DC, you know, you have to have a second conductor somewhere. Well, at Wardenclyffe, that second conductor was a huge iron stake right in the middle of the antenna.
uh-huh.
So only half of it was, only one of the conductors was earth ground.
Uh-huh. Yeah. So
Well, Tesla didn't really transmit electromagnetic waves. Tesla charged and discharged the atmosphere and the Earth. Basically, he was using a capacitive technique where he was using the permittivity alone, not the permeability and permittivity together to make an electromagnetic wave. So he was charging the Earth and discharging the Earth in and out of the atmosphere. He was creating an imbalance between the two. And he did use a generator to create the power. He just didn't have any wires to transmit the power, but he was getting the power from a generator. The reason he got shut down is because there was no way they could have regulated who took the power off the grid, and there was no way they could have charged for the power. So they just had they shut him down and said, we're going to go with wires instead, from what I understand.
yeah,
So we can at least monitor it and charge for it.
yeah. The person who was sponsoring him, I can't remember his name. He was a very wealthy man. He when he learned that um, Tesla's goal was to give everybody free power, free electric power, he said, no, we have to charge for it. That's why I'm investing in this, to make money. And so he just took all the support away from Tesla at that point. And then also Tesla's offices in New York City and his lab and everything was burned. And some people think it was someone did that deliberately to stop him from doing any more of this work, because they didn't want to lose their opportunities to make money.
Yeah, Tesla's sponsor was J.P. Morgan.
Yeah, J.P. Morgan, that's what it was. Yeah. So you see, there's same things going on today. If you produce something new in science, um, there are going to be people who oppose you. Now, on this nanotech crystal we're talking about, all the companies that make power plants, all the companies that sell fuel to them, all the electrical engineers and people that maintain the wires, they're all going to eventually be phased out if this is accepted. That's a lot of people. It's a lot of jobs. So there's going to be a lot of people opposing that technology. So that's why they're putting it first in cars and in
Well, there were been a lot of people opposing Marconi's technology too, but they didn't manage to suppress it.
right, but it didn't have quite the impact that this technology would have. This technology would affect every person on the globe if they use electrical power.
Something you also need to notice that to produce that technology, market it, and distribute it, it's going to require an incredible workforce. So what's going to happen is that if it's done properly over time, the integration process will provide for the migration of individuals from one industry to the other, hopefully so that there won't be any fiscally tectonic disruptions of the technology spectrum of our economy.
I think you're right, and I think if they don't do it properly, you'll have unions and all kinds of groups trying to stop them. So we've been discussing what needs to be done to get some revolutionary new theories accepted that seem to be better than the previous theories. And so we've talked about the impact of on the economy and on people's wealth. We haven't talked about another area, which is what I've been emphasizing in my regression to modern science. I'm going to emphasize that, and that is I have a religious background, and all of the regressive theories of modern science have taken a stance that opposes the truth of the Bible. And I don't think that's just happenstance. I think there's something behind that, some goals, some groups or parties that want to see that be the outcome. And so there may be other factors that will affect that. The work that I've been doing in science is compatible with what the Bible has to say. It's compatible with the creation that the Bible describes. It's compatible with the notion of the law of cause and effect, and the like in quantum mechanics, that law of cause and effect is abolished, and some people would say, "Oh, the people who are supporting quantum mechanics don't like the law of cause and effect because in the Bible there are spiritual laws, and if you break them, there's an effect which they call hell or something like that, and we don't like that. So we like everything to be based with no law of cause and effect." And so anyway, there's these other factors too that may be involved, and I'm trying to document those factors with the major theories of modern science that I call regressive. In other words, we're not getting closer to the truth. We know from logic, you put logic back into the scientific method the way it used to be, those theories can all be falsified. And so we need to find a theory that is better than those that doesn't, as far as we know, we don't know how to falsify it yet. And we can explain more data, and it's simple. Usually you think, well, the simplest theory that explains the most data should be the one we go with. And in my work, electrodynamics is explaining gravity, uh, is explaining how atoms and nuclei and elementary particles work. It explains the complete set of elementary particles that I accept as valid, which is 96 elementary particles. Um, and uh, explains it predicts the mass of all of them, it predicts their charge, it predicts their spin, their magnetic moment, the rest mass, and all that kind of stuff. And according to the standard model of elementary particles, even though it has between 19 and 29 adjustable constants representing still unknown physics, cannot do that. It has trouble just predicting the rest mass of an electron, much less the other particles. And that is interesting to see that, but yet it is promoted as the correct theory, and it is used as the basis for the Big Bang and all this type of theories that we have that talk about our origin. So, uh, anyway, those are some other things to think about. Are there any religious or anti-religious motivations that are driving science today?
Actually, I think there's science motivations that are driving religion. If you look, I'm a physicist, and I've seen too much evidence of intelligent creation or intelligent origins of the universe, and too many scientific laws state that left alone, an organism or a body in space will depreciate, the orbit will begin to extend, that molecular structures begin to degrade back to where they originally came from, even, just looking at iron. For there to be this type of structure, it almost mandates that there was an intelligent origin. And to that end, whatever name or face people want to put to it, I've heard all kinds, including extraterrestrials or whatever. But it does clearly, the evidence is that there is undeniably an intelligent origin there. And everything was set in order with mechanisms and a form and cause and function. And to that end, I guess the best definition of science would be the study or the pursuit to understand that which was created, or if you want to use the word he with a capital H, which he created for our own use, or regrettably sometimes it's abuse, but science is the pursuit or study to understand that which was already created. And to that end, I guess, there are a lot of other things that are added to, that man has added to, quote unquote, the evidences of what's already there that we've added on our own. And I guess that would be the definition of religion, but it's something that man creates. But however we slice it, there's still an intelligence out there that appears to be powerful enough to have created all of this, and we're humbly trying to sort it out. And I try to stay away from the entanglements of those that have muddied the water, shall we say, with a lot of their own personal self-seeking directions that are just there to all but enslave man under the guise of an honorable intelligence in the universe. But I think science, drives something that's a little bit higher than religion.
Who is this speaking?
Pardon?
Who are you? We only see your telephone number.
This is John Fiala.
Oh, okay, good. I recognize your name. Okay.
Yeah.
I see no particular reason why science should conceive themselves to be superior to religion or any other philosophy. What gives them the right to assert that?
Well, some of us,
Some of us,
some people, believing what they believe, have invented God and made God in their own image.
Well, that's an assumption on your part.
Yeah, there's some individuals, some of us men on this earth, have created God in our own image. But I think whoever that intelligent being is, I think he's got his own ideas, and I think it's best to just yield to whatever his ideas are.
Well, isn't that what religion's trying to do?
Oh, make God in man's image.
That seems, that seems to be an assumption on your part.
We kind of have trouble doing experiments with religion where we have possibilities of doing experiments with science.
Yeah.
I don't think that's the issue here. I think the issue here is that there's an assertion that there is a superior philosophy or a superior approach to knowledge, and science is that. And I don't see that they've demonstrated that they have such a superior approach.
Well, we can test theories in science. How do we test theories in religion?
You know what? He's got a good point there. Science, by mere fact, defines itself as inferior because it's trying to learn or search out or research that which is out there, which means that there's a superior that is elsewhere. So his point is very, very valid.
Well, I was getting more to the point of if you're going to claim you have a superior access to knowledge, then you would have to be able to demonstrate that that superior access to knowledge is somehow or another true. And the whole forum that we have here is essentially questioning that claim. At least that's my assumption of what's going on in the NPA and the CNPS.
Well, I'm been a member of the NPA and CPS for a long time, and it's not a religious-oriented organization, although some people who are members of it are religious, but others are not. And I think that our emphasis is on science, and
that's not my point, Bill. My point is that if you claim that you have a philosophy that can produce true knowledge, then you have to be able to demonstrate that that's so.
Well, I think as scientists, we want to, at least from my perspective, we want to show that we have to have logic incorporated in the scientific method, or we can't claim any validity or authority to science theories until we can have a way of falsifying them in a proper manner.
Does somebody have a phone ringing? Well, there's been events that myself as a physicist that are undeniable, that satellite photos in imagery that was in the late 70s, early 80s, there's a huge rock out in the Sinai Peninsula that after you wash stones with X amount of water, like in a stream bed, how they become very smooth, that over 100 miles from the next nearest source of water, this rock halfway up the side of a mountain, clearly water flowed from it and washed through a place where it looked like it was inhabited for quite a while. Now, that indicates that the testimonies that are given through different historical documents including, and one of them would also be the Bible, that would indicate that it affirms some of the historical precepts of that text. Now, has all of it been proven? No. At the same time, it indicates a higher intelligence that caused that to take place, and some of those other events. And back in the 90s, I used to design DSROVs, deep sea remote observation vehicles, for municipalities and the government. And I've seen images on a narrow strait on the sea floor of the Red Sea that where there's horses, hooves, and chariot wheels more than 100 miles from land in a very narrow path, and all kinds of evidence that at one point there was something that was dry and that these all traveled out there. And I've seen the evidence personally. I can speak to it first person. So there's somehow there was some force that dried out a portion of that land area that in one case is about 900 feet below the mean tide level of that that sea. And to this day, that evidence is still there. It's not been obscured or swept up by somebody, much like the way a lot of the evidence of that, I'll call it a campground, at what would be Mount Sinai has been swept away. But before the eruption, the volcanic eruption near Ararat, I've used satellite imagery that had a complete one-piece nautical vessel that was high on the mountain, which is now broken into one smaller piece and some significantly smaller other, but two pieces. And I've had in my hand a piece of the wood and the rivet that were taken from that. And there's an alloy that was a work-hardening alloy that was used to rivet those joists together. That we destroyed grinding wheels trying to cut into it. But there's some interesting material out there that speaks to historical events and texts that some of them are held by religious organizations and religious groups in history. But to me, I have to view it as a historical text that on some level, personal level, that has been verified, or that I personally have seen the evidence to support it. Now, some of the other information in the text I have not been able to support with evidence. However, enough of it has been supported to me personally that I am completely convinced of the integrity of some of the early texts. There's a lot of later texts that I would still, the jury's still out on, but some of the early historical texts I have an unconditional respect for because of how much of it I've seen personally.
Well, I appreciate your comments like that. I'm from a similar background, and if you go to the British Museum in London, you'll see evidence that they have put together and found where the Garden of Eden was and still is. There's actually a town there now today in Turkey, and they show you by where the rivers came from and where they joined, which is mentioned in Scripture and some other documents that they have. They were able to actually identify the valley there where the Garden of Eden was. And we've also, you mentioned the finding of Noah's Ark, and we had an American nurse, a male nurse, who went over there and using scanning technology was able to actually see the structure of the Ark. We had seen it from the air, and it was the right size and the right width, but we didn't know how to prove that is, the archaeologists did not know how to prove it was or was not Noah's Ark. And he goes over there, someone who's not an archaeologist, but very interested in the topic, and he takes the hospital scanning type things, and he's able to show the actual timbers and the internal structure of the ark, which is amazing. And other places have been found too that are in the Bible. So there's a lot of historical evidence that the Bible events occurred. And of course, one of the things the Bible describes is creation. And my work in the electrodynamic force, I have found evidence as a scientist that the electrodynamic force is the universal force. And the normal forces that are claimed to be in addition to it are the force of gravity, but we've been able to derive the force of gravity and get a better version of the force of gravity than any other previous one, as far as I can tell, just from electrodynamics, because we get two terms instead of one, which general relativity theory and Newton's universal law of gravitation just have one term, but there's a second term, and that term is what is missing and why they can't explain all the data. And but then there's also the strong interaction and weak interaction force, and we've discovered from the new NIST data, the 8 significant figures, that there is no longer any evidence, if you believe in conservation of energy, that the strong interaction, weak interaction force exists. Everything is a 1 over R squared force within nuclear isotopes, and that holds for 3,500 nuclear isotopes. And so so the Bible also indicates that the mechanism by which God created, if you do the translation from the original languages, was electromagnetic. And so I do a certain amount of Bible translation and publication, and you probably heard of Wycliffe. They are using my translations in hundreds of translations for different languages now, because I use what's called the root word method for translation, which is the method used for scientific translation. And they use more of a poetic type of translation, which tries to get the gist of the arguments, but it doesn't consider scientific information very, doesn't give much emphasis to it. So a lot of the scientific information that's in the Bible is translated in a way that is misleading. And so I like to go back to the original, or as close to the original as we can get, and to translate it as a scientific document, and for the science, where the parts are that have scientific type information. So anyway, I've been interested to note that my scientific work is now in step with the Bible. But when I started, that was not my goal. I started following the instructions of people like Isaac Newton and his mathematical principles of natural philosophy, which told how to make progress in science and to work toward a universal force if such a thing exists. And he says you make your empirical laws and you write them down, and then you try in each field, and you, in one field, like say electrodynamics, you solve the complete set of those empirical laws and get a more general law as a general solution, and then you see if now you can predict something in another field. And unfortunately, we didn't do that. Maxwell was working on that, but he died, and his followers, like Oliver Heaviside, decided to not use quaternions, but to use vectors, and he decided to use only 4 of the 6 empirical equations of electrodynamics to solve together simultaneously. And that's what's in our textbooks today. But if you solve all 6, you discover, all the results of special relativity, without the bad assumptions, come directly from electrodynamics. And you say, wow, well, that's probably one reason why they won't want to do that, because they falsify the special relativity. And then you find you can derive a better theory of gravity from those 6 equations, using the force of gravity as the force between vibrating neutral electric multipoles. And now you don't need the theory of general relativity theory either. And then you discover that the solution for the radiation reaction terms in the coming from the 6 empirical equations of electrodynamics requires a certain type of structure or building block for all electromagnetic materials, and that is in the shape of a toroidal ring, and that leads to an improved theory of the atom, and it leads to a physical explanation of quantum mechanics instead of a mathematical theory. So you eliminate these mathematical theories that are not physical, so much like quantum mechanics, and the law of cause and effect continues to go on. So my work has kind of paralleled the Bible, but I was working from rules that Isaac Newton put forward. He probably was a Christian, but he was working in terms of logic and experiment and that sort of thing. And he was trying to say how to make progress in that manner. And I think he had a better handle on it than most modern scientists have today, and that's why I follow what he did. And it's had unusual results and very good. So far I've been able to explain the force of gravity or the force of inertia from electrodynamics. I've been able to explain the results of special and general relativity theory and quantum mechanics. I've been able to explain the extreme ultraviolet emission spectra of atoms. Been able to explain more information about nuclear isotopes than any previous theory. In fact, I can predict without any fuzzy math or anything. I'm able to predict the spin and the mass of all the observed nuclear isotopes, and I'm also able to predict islands of nuclear stability that the current theories cannot predict, and I'm able to predict new ones that have not yet been observed. So we can go after and look at them, and one of those has been found since I predicted that. So, by the way, the quantum and the liquid drop model of the nucleus cannot predict over the spin of over 130 nuclear isotopes, but I can. And so it's been for theory. So anyway, there's a lot of progress being made there, and I'm now to the point of working on the origin of life and the relationship of life to electrodynamics. In electrodynamics, there are 2 types of fields. There's transverse fields and there's longitudinal fields. And the longitudinal fields seem to be associated with life. And it looks like we're now able to explain more and more phenomena. We're able to make meters that can measure the amount of life in things. We're able to make devices that emit longitudinal radiation and can recharge the atoms in cells and molecules in cells so that disease can be taken care of by the body, and you give it more energy and you don't need any kind of medication. And so that is very interesting. I've been invited all over the world to speak on these topics, and the last place was in Israel, and they have a lot of highly educated people there, and they're very interested in these kinds of topics. Okay, it's time for us to draw our meeting to a close. Are there any final comments that you'd like to make before we close the meeting?
Your notes on historical text, if you go back to what's people call the Torah, or the 5 books there, that's it hasn't been translated, and it's much more accurate for doing the scientific research that you're looking for. I just asked you if you spoke Hebrew, and I found that
I don't speak Hebrew, but I do use.
Yeah, I out of necessity, I had to learn some Hebrew or learn Hebrew to do what you were pointing out there, just the research on the original text.
Yeah.
By the way, your summation there, I have a lot of respect for that. Thank you.
I appreciate your support. Not everyone in our group necessarily has that point of view, but it is good to see what the various points of view we have. That was why I suggested having a meet and greet for one of our meetings, because we don't know a lot about each of our backgrounds, but if we did know more, we could understand better what you are saying and what your motivation might be and that sort of thing. And I think it helps us to communicate with one another, to know that about each other. And so that was why I suggested that. But we get a little bit of that background just in these conversations that we've had today. But next week, Franklin Hugh will be back. And if you have something you would like to talk about for the meeting, send him an email, and he will. And if you want to do a presentation, like a PowerPoint presentation or something like that, I'll send that to him too, and I think he will let you speak and use that PowerPoint presentation if you'd like. And there's a way in this Hughes to put a PowerPoint presentation in. Like on the screen right now, that is a PowerPoint presentation, and if I click on this, you'll see I can just change the slide, even just one slide to the next. So your slide can be put in there, and people can see what it is. So say this for here. I think Franklin was going to do this one, and this is some data and that sort of thing. And so we can do that with your presentation if you send that to him in time. Or he can also take your screen and show it to everybody, and the screen would be the PowerPoint presentation on your computer if you're coming in with Fuse, and that can be shared that way. Okay, if there's no other comments, I will then cause the recording to end. And if you want to talk for a few more minutes, we can do that after I stop the recording. It seems to take a little while for the recording to stop command to work. I don't know exactly. Maybe it has to do with how far away we are. Does anyone else want to chat anymore before we depart? You have a good day, pal. I'm talking to Pal.
Thank you. Thank you very much
Yeah,
for your presentation.
yeah.
I was again refreshed to see your nexus between sciences and Bible.
Yeah, yeah. Well, that's another conversation that could be held sometime, and my other organization, Common Sense Science, could do that because we have more religious background in that particular group.
Well, until next week.
Have a good day. Have a good week.
I suppose the recording is off now.
I think so. but it hasn't said it on the screen, but I clicked it, and so it's supposed to be doing it.
Sometimes you have to push it more than once because first time it doesn't register or goes into a queue or something.
It says it's not recording,
Okay, well that's probably good.
so I didn't hear the comment.
Yeah, I didn't hear either, but then I was doing other things also. Uh, Multitasking has that risk.
Yeah. Jim, are you still online?
Yep.
Jim Marson? Same car, are you still online?